Hi, this is Dirk from Metascan. Today I want to talk to you about human-centric synthetic data. Not so long ago, I was a software engineer at Google working on a project to protect YouTube from spam. And we were tasked to build a liveness verification app. That means you have a mobile device and you record a video of yourself performing some task, like turning your head to the left or right. And then the app determines from machine learning models if you are alive or a spoof, like an image recording of a video of another tablet or a photo to increase the friction for those abusers. And these models, like they're trained through deep learning, like software 2.0. And what do I mean by that? I mean images plus labels. So in our case, we need a lot of images of human faces. And we have specific labels. For example, the head pose is alive, is a photo, and so on and so forth. And this now comes the question, where do you actually get these images from? Especially like in the human domain, where you have a lot of biometric data, this is not so easy. So option one, you go into the real world and you take the pictures. In our case, we had to build like a custom data collection app for mobile devices. So you have a high setup cost. Then, as you need to collect data from thousands of identities, to scale this data collection, you need to distribute this app to your data participants. And normally you will incentivize the participants with some money, such as they sign a consent. Like this, especially biometric data is heavily regulated through GDPR, AI Act, and depending on the country, it's not super easy to do. And most probably you will go through a third-party provider that helps you with the scaling of and distributing of this data collection. And then you have another very big problem, which is the labels. The labels you will receive from your participants, if they safe label themselves, like the skin tone, age, depending on what you need, will be very low in quality. Also, the third party only has limited ways in verifying the quality. So you will have a large team that you probably have inside your company that then needs to make sure that all of these labels are accurate. They manually need to annotate the labels probably. They need to check the labels. They need to check also the collected data. So it's very complicated. And the other big problem that you have is this is a very use case specific data collection. Next time you have a different problem, like in our case, we were later tasked to have an age verification system. You need to redo all the data collection. So insanely costly, and you have very slow iteration cycles. What is a better way to do it? Use synthetic data. Like, for example, Microsoft. They 3D scanned a lot of people and are now able to produce all kinds of images of heads, which are perfectly labeled, by just using synthetic data. And what do we mean by synthetic data? So there is all kinds of synthetic data. So you can have tabular data that you generate synthetically. You can have numbers that you generate synthetically. But in our case, we refer to as like synthetic training data as are labeled images made using computer graphics. And more specifically in the human domain, you most probably have a large scanned data set of like 3D scanned identities like human hands, human heads, maybe full bodies, maybe even 4D scans when people move around in a 3D scanner. And then you have a rendering pipeline that can transfer these things into labeled images. And why should you use synthetic data? First of all, you have clean labels without any annotation errors. And this is super important. Secondly, you can generate labels like hundreds to thousands of landmarks per model, like per image, that are impossible to generate when you have manual or like some human in the loop that annotates these labels. And also, it's very easy to control the variation of your data sets once you have your data pipeline in place. And now, how do you define good synthetic data? How do you measure quality? And in this sense, you normally rely on free access, like the richness of labels, the realism, and the diversity. And let's dive into each one of them. Firstly, realism. Why is realism so important? And probably why is it the most important axis? This is because when you train your machine learning model on not real enough data, it won't work in the real world because the synthetic data domain and the real world domain would be too different. So there would be a large gap between these two domains. And you want to have this gap as close as possible. So here, for example, I took from an old computer game, The Sims, not very real. But today, in the right setup, you can have photorealistic quality and also at large scale. It's a very important axis. Secondly, humans are very diverse. So there's a large amount of humans that are probably pretty similar, like white, male, wearing the jeans, like this person. But then there's a long tail of very different persons. Like when you go to the European Eurovision Song Contest, they wear differently, they behave differently, they dress differently. Like humans are super diverse. And then also to make sure that your model covers is fair, like for all ethnicities and all humans, you need to take into account gender, skin tones, ages, eye shape. So diversity is also very important. And then, of course, richness of labels. You can have like very easy coarse labels, like just bounding boxes, and then get super fine-grained, like segmentations, poses, or even like thousands of vertices. And this axis is awesome. And then you need to have a scalable process. So you can always move some axes better through the work of manual labor. Like if you go to one of these movie makers in Los Angeles, they probably 3D scan a person, and then there is a large amount of people like 3D artists and visual effect appliers that make movies indistinguishable from the real world. But this at the cost of many, many, many hours of costly manual labor. So synthetic data needs to be procedural. And what I mean by that? So normally you would start most probably in your pipeline to generate these images from a parametric 3D model. Then you put poses on top, then you put accessories on top, and then you have the render environments. Let's go through each one of them. What do I mean by a parametric model? So you will have some parameters, like for example, you will be able to select a gender. Like if you talk about humans, you can probably have thin people, very muscular people, and all this will be parameterized to generate, like in this case, a 3D model. And then on top of this, you will have, like when you want to simulate real situations, like a person sitting down or a person performing an activity like golf, you need to have a sequence of poses that you then apply to your model. And this also needs to be captured, most probably in some 3D scanner. And you need to have a large database of these valid poses. Next step is then to apply accessories. So you need to dress your humans. They wear different kinds of clothing, hats, masks, glasses, headphones. And then you would put them in some kind of environment, like a car or different lighting, and render your images. And before ending this talk, I also want to give you some more examples where synthetic data has been used to train these models. So when you have a VR headset like the Quest or Apple Vision Pro, and you have this hand tracking where you can basically control your eye elements with your hands, then this has been explicitly trained with synthetic data. So they scanned a lot of hands, and then through this pipeline, generated lots of labeled images, which now allows them to use this model in the VR headset. Also, when they use Snapchat, like, and you need these dance landmarks, where they recognize your face and then you apply filters. This most probably also has been trained with synthetic data. And now, the next big thing that will be coming is that you probably only take one or a few pictures to get like a photorealistic model of your head. And here as well, these models will be trained with synthetic data. So thank you again for listening. I'm sorry that I couldn't make it in person today. I'm in a flight to Singapore. If you have any more questions, write an email to dirk@metascan.ds. You can also go to our website by scanning this QR code or find me on LinkedIn. Thanks again and see you next time.